Hi everyone, I'm Pengfei Song. Here is a video of homework 5 of the class Probability and Stochastic Process. And here is the second problem. Let's read this problem firstly. Given fxy equals to 1 divided by ay squared x and y is greater or equals to 1 and 1 divided by y is less than x less than y. And firstly, draw the non-zero definition region of fxy. So firstly, let's solve this problem. We know that fxy equals to ay squared x 1 y greater or equal to 1, and here is the condition. We know that. So let's draw this. Here is x, y, and y is greater than x. So let's draw the line is x equals to y. And we need to draw the line that x equals to 1 divided by y. Here is x equals to y, x, y, and this line is x equals to 1 divided by y. And this point is 1, 1. So we know that this region, this non-zero definition region of this function is like this region. Yes, and the second problem, find A so that fxy is a valid joint density function. So let's solve this problem, and we need to calculate. Let's integrate from 1 to infinite this from 1 divided by y to y dx dy. Let's solve this. Let's calculate this one. It's equals to from 1 to infinite a y squared, and from 1 divided by y to y, x 1 divided by x dx dy. To the end, we can calculate it as the result is like minus 2 divided by a. We let w equals to ln y. We can get the result w e to the minus w from 0 to infinite minus 0 to infinite e to the minus w dw, which equals to 1. So we can get the result that a equals to 2. And the third and fourth problem, let's solve it. Let's solve them. We know that we can calculate fy, which equals to from minus infinite to infinite fxy dx, which equals to from 1 divided by y to y y squared x dx, which equals to ln y divided by y squared when 1 less or equals to y less than infinite, and this is 0 when otherwise. Let's draw it. It's like x, y, and oh no, it's y, it's f, y. Let's draw it. When y is big is greater or equals to 1, it's 0. And we can draw it like this. No, we can draw it like this. Yeah. And we know that from 1 to infinite to integrate this function ui, which equal to 1. So we know that fy is a valid probability density function. We can know that. And then let's calculate fx, which equals to from minus infinite to infinite fxy dy. And after calculation, we know that when x from 0 to 1, which equals to half. When it's from 1 to infinite, fx equals to 1 divided by 2x squared. And so we can draw it. We can draw it like it's x, it's fx, it's x, it's fx, and 2, 1 is half, and then it's like this. So that's the result of this problem too. Thank you.